shed, we've currently represented the plan or the frame layout of the plan, but we haven't allowed for a door or a window. And so we're going to now break into that standardized frame and then adjust the frame as necessary in order to make that work. The first thing that we're going to do is to add a double door. And there's multiple components that we need to think about with this door. One is the door leaf and one is the door jamb. In order to represent this, I'm just going to draw this roughly in plan at the moment. The door leaf that we're creating is 720 millimeters long and 35 millimeters wide. It's 2040 tall, which is going to be relevant later when we're drawing this in elevation, but it doesn't really matter now. The next component is the door jamb. Now we can get door jambs in a variety of different sizes. I'm just going to copy from this detail and then we will adjust this as necessary. So 138. Sorry, let's do this in a slightly slower way. 42. 138. 30. 44. 12, and then back to the start. Now the idea of a door jamb, let's rotate that around, is the door sits in here or thereabouts. Now depending on the door jamb, so this is just a standard jamb with a detail that I could find to explain this. Ideally we're going to choose a door jamb that's the right sort of size for the door that we're going to use. So typically we want one that's a little bit shorter, that's the size of the door or thereabouts. It's not exactly right because we need to allow maybe 1 millimeter on this side and we need to allow a couple of millimeters, so maybe 3 millimeters on this side. We're going to have a hinge in here, and then once we do that, typically that's about right. It might end up being another millimeter size that way. We also need to choose the right sort of jamb that fits for what we're trying to do. The first thing I need to understand is, do I want the door to swing in or the door to swing out? A door that swings out is better because a door that swings out will probably be better sealed, but typically for front doors we like doors that swing in, so that's how I'll explain this at the moment. Also with a door that swings in, the hinge mechanism is on the inside, and that again is generally safer or more secure. So where does this jamb sit? Ideally the jamb is sitting in relationship with the frame and our cladding. And so we're normally going to want to line up the inside of the jamb with the inside of the frame. So we can see that that's working pretty well. Now if I was to take that back to where it originally was, let's move it out to here and extend this a little bit more, we can see that this would, if we were trying to match this up perfectly, this would be an overall of 135. And so it's pretty close to what we were originally basing it off. Now, in order to understand this, we need to now double this up, see what it's going to look like in the other direction. So let's move this back out just to make sense of what I'm talking about. So this isn't just a single door, this is a double door. So we're going to have another 720. And we can have this 720 working in a couple of different ways. Again, we want a little bit of a gap, so we might allow 2 millimeters, maybe 3. The other thing to understand is, where is it hinged? So the hinge point happens here. So the hinge will normally sit just beyond, let's try to draw a proper circle, just beyond the jamb. What that'll mean is the hinging point is here. And so if I was to draw another arc, I need to make sure that the space that I'm leaving allows enough room for the doors to open past each other. So if I have a door that's swinging like this, and if I was to mirror a copy of that, I didn't do that very well. Let's try that again. Move, mirror a copy. We can see we've got this awkward little place where there's a bit of an overlap. So in order to fix this, it's probably better if we allow just a little bit more width so that when the doors open, they're not bashing against each other. Now we can do a couple of different things. Obviously there's a gap that's left over. And so the gap that's left over is not fantastic because it means that there will be wind, maybe some water that travels between. So we can fix this in a few different ways. Now, depending on the manufacturing of this door, we could split this door, and so it has an overlap, or we could have a plate or an angle or something which makes this overlap. So if we were to make this work really easily, we'd probably separate it just a little bit more. So let's move it back another 2 millimeters. And I could suggest that there's going to be a piece of aluminium. For argument's sake, let's suggest that that's 30. By 3. By 3. And we'll change that to be aluminium. And the idea is that this is screwed against one of these leaves, and that means that the other door closes against these leaves. So we have to open one door first and then the other. Now, once we've done all of this, it's giving us a better understanding of how large the overall size of the door is. And so we can see that the overall outside of the frame is currently 1511. We also need a little bit of tolerance on the outside of the frame. So we might add an extra 5 mil. Before we do that, we're just going to center it. So where's the center of this door? I'm just going to draw another simple line just to represent that here. And I'll move this, drag, so it's centered with this line here. And then I'll move this into place. So the outside of the frame is aligned with the outside of the cladding. Now we see that we've got studs. These studs will exist, but they might be above the door. At the moment we don't want them, so I'm just going to delete them. I could move them away if that's helpful for me to remember to put them back in later. But we can see it's not exactly working in exactly the same way as our sheet was, because we had one sheet of plywood that runs past the end and another sheet of plywood that runs short of the end. Now we centered the door is the middle, so that wasn't a mistake. It's just because the framing works differently in different circumstances, which is fine and which is normal. In this case, it means that I can reduce this distance. So I would take it back, and then I need to give myself some more tolerance. So that might be 3 mil or 5 mil. And I'd pack between this stud and the jamb. And typically, I'll also want to have a double stud here. So I'll bring back a second stud here. Now, based on this detail, where do I want the plywood to go to? The plywood is essentially going to do the same thing. The plywood will stop in line with the stud, and then I'll have some type of architrave to hide that relationship later between the outside or the inside face of the jamb and the inside face of the cladding. We've got the same thing, well, ideally we want the same thing to happen on the other side. So I'm going to delete those and copy these. Move, mirror a copy. Because wherever possible, if I can keep that symmetry and I can make sure that the detail is working the same on both sides, that's going to work really well. So now we've brought in our door. Again, in a lot of detail, we're explaining how this is working because we're trying to understand full framing detailing. And then in the next tutorial, we're going to have a look at how to do the same thing with a window. So we originally had a whole set out of this wall. Now, of course, this set out still exists over here, so we didn't waste a lot of time. But as I was explaining, I'm deliberately drawing in such a way that I know that I'm going to need to change what I'm doing because I'm not wanting to think more than what I'm showing. So I want to explain if we were drawing something simple, and then if we need to change it, why are we changing it? So we end up having a situation where each of these timbers has a space of 400 or less, because that was the maximum center that we were allowing for our wall. Now, if I want to be really thoughtful, I could adjust this 10 millimeters. So that's still a spacing of 400 millimeters. And that way I don't confuse myself later when I'm trying to figure out where to put maybe a screw or a nail into the plywood. I can add these studs back in later. At the moment, they're not necessary. They will go, like I said, above the door if there's space above the door. But for now, it's really not necessary. So for now, we'll delete it. So we've now got a shed. The shed's got a double door at the front. The next thing that we're going to need to do is to add in our window. And it's going to be a very similar process to what we were just looking at with the door, at least in plan. And then in elevation, we're going to see that there's a few small changes.